So hi everybody and welcome back to our C++ tutorial series for absolute beginners. This is video 324 and we continue with our exercise. We stopped here at enumerators and now we have this template parameter, but we skip that, and lambda expression we skip, also required expression we skip, and this concept, because these are future topics. But we jump here to the properties and we repeat here a little bit. And in this video we start a repetition a little bit about the R values, but just short, and let's jump into it. So first of all, I click on this R values. We jump now to the properties and you can see here the properties. You should know them, I think we talked about them. If not, now we repeat them very fast. So first of all, here an R value cannot be taken by the built-in address operator. I think you know this is the ampersand, and when we try to take the address, we do this normally for assigning, for example, a pointer, the object, and then we take the address. This one will not work on R values. That's very good, because so you can test also if something is an R value. The second thing is here, an R value can't be used as the left-hand operand of the built-in assignment or compound assignment operator. So if you try to assign something to an R value, let's say here is an R value, let's say this should be an R value. Oh, let's make it so 42 is an R value, and then you try to assign to it, that will not work, right? Anything. But we know that we can assign to a function on the left hand side sometimes. This is the new thing that is not, you see it not often, but when the function has a return type of a reference to an object, then this is possible. But if it's an R value, it's not possible. That's very important here as well to know. Then we have this one here. An R value may be used to initialize the const L value reference, in which case the lifetime of the temporary object identified by the R value extended until the scope of the reference ends. If you want, you can try to make here a code example. I show you here a very simple one. You can stop the video if you don't want to see it. What I have, it's a very simple one, and I jump to it. So you can see this is very simple. It's not a real code example, it's just one line. So you can see I make the const L value reference and I just called it LREF, and here is important, I used an R value. In this case I used the number 2, it's just a PR value, we know that, and I assigned it. Now here also important is, it says here the lifetime of the temporary object identified by the R value is extended to the scope. And what does this mean? Let's watch this one here as well. Let's make it so. It means I can use now this name here within the scope, and you can see I made here a local scope. We can make just this brackets here, and then you can see I have made this a local scope, and within this local scope I can use this name here and do something with it. In my case I just print it out, and you see I have here no errors. And when I start this, it's here anywhere const, I think that's this one here, it works. So, but important here to note is, if you want to try now to use this LREF out of the scope, this one will not work. But there are other reasons too why it's not working, because this name is going out of scope, because it's a local variable also, so that will work also not. So there are even 2 reasons why it's not knowing, but you have to just to know here, you can use this name within the scope. And why is this a little bit strange? Because think about it, about this one here. We learned already references, and we learned a reference need normally an already existing object with a location, because it refers to this place. So, and that is strange because an R value has no location, a stored object. We can't refer it normally but here with this special case, when it's a const, then we can use it within the scope. And that's here important to note, because when you go out of the scope, this one will not work. And let's jump here also to the other one. This is similar. An R value may be used to initialize an R value reference. So here was an L value reference, and now we are talking about an R value reference, and also with the same with lifetime. And here again, here an example, very simple one. First of all, what is an R value reference? Remember, all time when you see two ampersands here, this indicates already an R value reference. I called it just RF, and I assigned it again here a PR value. And the same thing like here, the this one here you can use within the scope again. Here you can just use it again. And that's it for this one. Let's go there and let's watch the next one here. Here it says when used as a function argument and when two overloads of the function are available, one taking R value reference parameter and the other taking L value reference to const parameter, R value binds to the R value reference overloads. Okay, and here let's read this one. So it does if both copy and move constructor are available, an R value argument invokes the move constructor, and likewise with copy and move assignment operators. And this one is actually the important part to understand here. But let's watch an example first. So here again, we have this two, but this time these two are used in a function as parameter. Let's scroll a little bit up. I think I have here. Yeah, here I have a function and I have here parameters. And you can see the one is an R value reference. This is the this one here with const. You don't need a const, but I made the const here standard. And then we have here an L value reference also with const. And we learned just now R values, right, can bind to an R value reference, or, and that is here a little bit this also what you keep in mind, to an L value reference. And important is here, when this happens and you have this two overloaded functions, you can see they have the same name and they are overloaded because just the parameter are different, then the compiler will choose this version here. Even it could choose also this one. So the compiler has the choice here, right? And the reason, and that is the important part here to understand, the compiler will choose this one here is because the compiler can optimize behind the scene with a R value reference better. What means better here? The R value reference, when you see this one, then you have to think fast about move constructor and assignment operator and all this kind of stuff. Why is this so important? Because the move constructor we learned will avoid a copy, right? And that's why the compiler will try to choose all time a R value reference instead of a L value reference, because here the compiler will not call a move constructor, which means when we have a class, in this case it's a char, this is not a good example, but let's say we have here a custom class which we create, and our custom class, it's called like my class, and my class here is a very big class with arrays of million data. Then think about it, when we have a move constructor, it will not create a copy of this million big data of my class. Instead, it will just move the resources here so that it can avoid a copy. In here, it will create, when we have not, for example, this one here available, then the compiler will choose this one, and internally it will probably create here copies of this big data, which will influence your performance. Especially, like I said, when I have a class with an array with millions of data, then yeah, that will be visible in performance. So that's the most important part about this R value reference. When you see this one, that should give you a hint. This is for the compiler to avoid a copy. And how does the compiler do this? You need also define this move semantics, that what we talked a little bit already, which is this move constructor and assignment move assignment operator and so on. And with that said, I think we stop here and go next time here a little bit more in the properties. But if you have any questions, like all time, write in the questions. See you in the next video. Bye, good luck, and like all time, have fun and never give up.